Hi everyone, welcome to today's webinar entitled How to Reduce Your Spend on AWS. My name is Joe Ziegler. I am the Startup Business Development Manager for Asia Pacific. I'm also a software developer, a CTO of different startups, and I work with enterprises additionally with AWS. So this is going to be a webinar is applicable for people in government, startups, enterprises, and even individual developers. Also, you'll see my Twitter handle there on the screen. Feel free to follow me if you're interested in some of the work that we're doing within APAC. I especially like to tweet about new features that we have available and work that we're doing with startups. So let's go ahead and get started. Just a little bit of housekeeping. There will be a survey at the end of this webinar. You'll have an opportunity to fill out that survey, and if you do and submit it, we will give you $25 in USD AWS credits. Also, we'll see if we have time at the end here to take some Q&A. If your question is not able to be answered in that time frame, you can indicate on that survey that you'd like us to contact you. We'd be happy to follow up, answer any of your questions, or have one of our account managers contact you. So let's go ahead and get started. Now, before we actually get going here, I'm just going to bring up a quick survey here, and I just want to see kind of what our audience is like today. It's a little harder on the webinar because I can't see you guys. So if you get a chance, could you just vote on this survey that should have popped up on your screen? Give me an idea of kind of what you guys are doing, what you're interested in, and I can just tailor this talk a little bit more to you. So your voting is going on now. I'll just let it vote here for just a couple more seconds. Great. Well, it looks like yeah, pretty heavy startup and enterprise crowd today. Some individual developers and some government. Great, great. Okay, so let's talk about how to reduce your spend. And this subject sometimes has a bit of overlap with what we call total cost of ownership or non-ownership in the cloud. What I really want to talk about are techniques you can use to spend less on AWS. So Amazon's a bit different in the sense that we are going to work with you to actually spend less money on us. And our goal is, really we're on the same side, and we only succeed if you succeed in what you're doing. And part of that, in succeeding is going to be using our services efficiently and be able to reduce your overall spend. So there are some specific benefits about using Amazon Web Services, which basically you can leverage overall to reduce your spend. And some of you might have already kind of heard some of this, but bear with me to talk about just a little bit. And these are the tenets, these customer-facing tenets that we talk about quite a bit at Amazon. It's elasticity of the cloud, it's on-demand resources, it's a pay-as-you-go model, and it's the ability for you to focus in on your own business and remove this undifferentiated heavy lifting. And now these four tenets, they come together to give us different innovative ways in order to reduce your spend. And you're going to want to take advantage of these different techniques. And how they build on top of elasticity, for example, in a pay-as-you-go model. And I can even talk about some customers who have gotten extremely creative, for example, utilizing pay-as-you-go in order to reduce their spend. So just really quickly, if you're not familiar when we talk about elastic capacity, this is something we talk about quite a bit at AWS. But if you think about cloud computing versus the old world, the traditional IT world, in the old world, you always had to provision some amount above what your need was. Usually, 10, 15, 20% above your capacity, in order to have some room and some margin for errors. And that really, that meant that you had quite a bit of waste because you always had to provision for this peak capacity. Regardless of what your actual IT needs are, because it takes time to provision things. It can take months, even half a year sometimes, to provision equipment. And when you talk about all the different types of usage patterns, we talk about an on and off usage pattern. I'm only using my resources maybe during the day. Maybe my developers are coming in from 8 to 7 or 8 to 8 or something and doing work. Or I'm in a startup that's having fast growth. I just got featured on TechCrunch and I'm growing really fast. Or maybe I've got something that's really internet-facing, customer-facing. I have no idea what the demand's going to be. Maybe I'm selling tickets to a concert. Maybe I'm launching a new application that customers are using, and you get this variable workload. And then you could even have a predictable peak workload. Let's say, for example, you've got an internal application like payroll, and maybe at the end of every month they have to run reports, and it's always going to be predictable at the end of the month. Well, regardless, when we talk about elasticity and traditional, you know, infrastructure, it's basically a lose-lose scenario when you don't have the elasticity of the cloud. Right? When you're turning on and off resources, all of that is waste. Even fast growth, you have to provision ahead of time. Everything above that curve is also wasted. And predictable peaks, again, anytime that you're not utilizing all your server capacity. The interesting thing is also when we talk about something with variable peaks, even to me, even a worst case scenario of wasted money is wasted opportunity and your ability, to serve your customers. And there you get dissatisfied customers. If you guys have ever been to a website when something's extremely popular and you get an error or the site doesn't come up or you're not able to book tickets or you can't see the weather because there's a big storm coming in or you can't go shopping because, it's during the holiday season, to me that's even a worst case scenario. And this is really important when we talk about reducing your spend on top of us, because when you turn off your cloud resources with AWS, you stop paying for them. And it's a pretty simple concept actually if you think about it. But think about all those computers that you have maybe in your traditional office or your hosting center, for example. When those computers are turned off, you still own them. They're still depreciating. You still have to pay support on them. You have to pay for the air conditioning, the networking, the people that are the hands on top of the keyboards. For AWS, literally, once you turn that compute instance off, you're not paying for it anymore. You might be paying for some of the storage that it's using because you want to persist it, but you're not paying per hour for that compute resource. Even more interesting enough, a lot of our software partners, they license that software per hour. So if you can imagine, in the old world, if I bought a product from some of our partners we've got now, like SAP or Oracle, I would sign 1 to 3 year license, and I would pay the same amount no matter how much I utilize it. We have customers who might run an Oracle database. They might turn it off at night or on the weekends, and they no longer pay that licensing fee because they're taking advantage of a licensing, it's a per hour pay-as-you-go licensing model. So this is a very fundamental concept, but it's really key in how you're going to be able to do different kinds of cost savings. So looking ahead, what do we mean by this elastic capacity? Now we have the ability to provision exactly what we need. And very importantly, we have that ability to scale that back down. So, for example, in this particular slide, talk about predictable peaks. If I know I'm not needing everything, I can turn off the resources. I don't have to keep paying for those resources, or variable peaks, for example. If I have a big spike in usage, I'm able to scroll things down. So that's a very important concept. You only pay for what you need and when you need it. And this is going to give you a lot of flexibility when it comes to controlling your costs. Another really important aspect, too, when we talk about overall costs or overall cost of ownership is, how much time of your precious IT, teams, these highly paid skilled people, how much of their time is actually, invested in maintaining this infrastructure and keeping it going versus actually, differentiating yourself from the marketplace and creating new benefits for your customer base and creating new benefits, for your clients. Even little things, talk about running backups. Who's managing running backups? Is it cheaper for you to do that through your own resources on your own, or is it cheaper for you to pay a low hourly cost to, use something like our relational database service, or RDS, where backups are automatic. You don't have to worry about it. Where restoring from it's a click away. And that is saving you costs. You're no longer spending, those precious IT resources. Highly paid, skilled individuals who aren't actually doing anything to differentiate yourself in the marketplace. And so that's another really important aspect when we talk about doing cost savings. Are you leveraging managed services or not? Okay, so that's a little bit of a tee up on where we're getting at. Some of the aspects that I'm going to build on top of that. We talk about pay-as-you-go, elasticity, and managed services. And so this brings us into really, 3 different ways that you can take advantage of cost savings on top of AWS and reducing your current spend. And that's going to be based on economies of scale, different types of pricing models, and then the really juicy part that I like to talk about, especially if you're technical, is cost-aware architecting. This means you can actually develop your application to work in different ways to run significantly cheaper. And that's a pretty cool concept. I mean, when I was a software developer, I never thought about the cost of the hardware to run my software in. I just wanted the biggest, baddest hardware I could get so that my software, ran really fast, and it made it look like I was a really good programmer. But now with AWS, you can actually make different choices on how your software is actually architected, and this will dramatically affect your spend on top of us. This is very important, especially for you guys that are startups too. You've got limited budget maybe you're working with, and so every dollar you save might be another developer you can bring on board. It might be another month that you can run at a different burn rate. So it's extremely important that you architect for cost savings. So let's start off a little bit. I'm going to talk about economies of scale and how you benefit on top of AWS for cost savings. First of all, we have a lot of different internet businesses that run on top of us. Power like Netflix, for example, in the U.S. is the biggest cable provider in America, consuming 25% of all the U.S. bandwidth when it peaks. They're running almost entirely on top of AWS. This is a massive amount of scale. If you guys have used any of the startups that run on top of us, Foursquare, Flipboard, think about all the data that's in Dropbox right now. Dropbox running all on top of AWS, leveraging our simple storage service for the back end. All that data is running on top of us. This means that we have a tremendous amount of scale. We are adding so much capacity per day. It's almost unbelievable. And we have all these different types of use cases, and these are different things that we're solving over and over again. Media streaming, right? So we've got media streaming services set up that meet the requirements of the largest media streaming companies in the world. NASA used it in order to stream for the Mars Endeavour landing, for example. Netflix, who I talked about. Think about big data. We've got like Airbnb, for example. All those check-ins are being processed on top of us. NASDAQ storing trades down to the millisecond with historic data on a simple storage service. Gene sequencing from Unilever is all running on top of this. This means that we have to have the amount of compute capacity to power these businesses and to bring on more customers. And so this leads us to some very interesting statistics. Now, believe it or not, when Amazon.com, who's a customer of ours, in 2003, it was a $5.2 billion retail business, almost 8,000 employees, a lot of servers at the time. We actually every day add the same capacity as Amazon.com had in 2003 to AWS's overall capacity. That's every single day we add this type of capacity. That means we can run extremely lean. And we come from this retail background. So we believe it's going to be a low margin, high volume business, and that comes from our whole retail DNA that we've brought over. And this is quite interesting then. This kind of puts us into this, this virtuous cycle where as we get more customers and as we get more usage on AWS, we invest in more infrastructure. We get more economies of scale. In return, we actually reduce our prices. Our margins don't go up. As we get better at what we do.
Welcome to GoToWebinar, Web Events Made Easy.
So, that would just give you some idea on the different economies of scale that we have. So let's talk about pricing models. And we've got different types of AWS pricing models available. And this is going to change exactly how you can actually consume our resources. This is extremely, I think, important when we talk about compute, but it applies across the board. Now, so first of all, everything is pay-as-you-go. So we don't have any contracts. We don't have any commitments. And you just turn things off when you don't need it. I think all of you guys probably know about this. Now, what some people might not know is we actually have tiered pricing and volume discounts. So you can reach different levels of different volumes within our different services and take advantage of discounts. And I'll show you different ways that you can do that. Once you know your usage, you can start using what are called reserved instances. We've got this reserved pricing that I'll go into. And then our lower pricing, we actually are going to pass that on to you as it comes about. You don't have to re-sign up for a service, for example. If we drop the price of using simple storage service, you get that automatically. And even last year at re:Invent, we had a major customer on the stage with our CTO, Dr. Werner Vogels, and we actually dropped prices that day with the customer on stage, and that customer said, wow, you guys just saved me a few $1 million today. So you get that automatically. That's the great thing about our pricing model and the subscription model. You don't have to re-sign up. It's not a special. It's not expiring only. It's not like if perhaps you sign up for a phone service, only the new customers get the new phone, but you've been a customer for years. Everybody gets these price reductions. So, interesting things, you can pay less when you use more. So we have volume discounts. Take, for example, storage, for example. As you move up, and this is just an example, you'll see all of this pricing is up front and on our webpage. Take, for example, storage. As you move up in higher tiers, the cost per gigabyte does drop. Also, data, for example, we don't charge for data in. All data in is zero charge. Data out, we do charge. But again, as you consume more, we're able to drop those prices significantly. And we also have that concept of reserved instances. So I'll dig into reserved instances more in just a second. But if you actually, purchase more reserved instances, we're actually able to give you a higher discount on this. And there's some interesting ways that you can do this. You don't actually have to be, for example, the only person consuming the different services in order to get to these discount tiers. If you're using something we call consolidated billing across your entire organization, we'll aggregate those values together. So, if let's say you're running a large enterprise with lots of development groups, pull all those development groups together, put it under consolidated billing. If together these groups meet a discount tier, we'll apply that tier automatically to your bill, and so you'll save money. Same as if you're a reseller. If you're a reseller and you've got your own AWS account and you're bringing up different customers on top of your own invoice, you can take advantage of that cost savings and either pass it on or keep that to increase your own margins. So we've got these different purchasing models, and I'll go into how you can use these and how you can use these to, specifically to reduce your spend. First, way over on the left, we've got a free tier that I'll go into. And the free tier is actually quite comprehensive. We'll get into this. On-demand pricing is probably what a lot of people are used to. That's kind of the default pricing model. You turn something on, you're going to pay that per hourly fee on top of us. Either Linux or Windows boxes. It's going to include the licensing for all these, for the Windows licenses, for example, and it can also include per hour charge for some of our third-party apps, depending on how they want to license that out. And then we've got these reserved instances, and this is when you actually know your workload and you want to commit to using a particular type of instance, the size of an instance within a particular region. And then you've got spot instances. And I'll get into this a little bit. Now, spot instances are based on our unused capacity. So really quick, the free tier, there's actually a lot that you can do for the free tier. If you're not actually using our services right now, or you're not a current client, check out that free tier. You can do quite a bit. It's just at aws.amazon.com/free. But just right out of the box, when you talk about compute, you get a year free of compute on Windows or Linux instance. But there's actually a whole range of services. You can basically try out pretty much everything on top of AWS. You can try out our compute. You can try out some big data, simple storage service, workflow service. Lots of different types of services available within that free tier. Data pipeline, RDS. You can run RDS free for a year, right, on a micro instance. It's a free database. That you can run, a fully licensed version of SQL Server Express, and you can run that for a year for free. So there's a lot of things that you can do on that free tier. And surprisingly, one thing is, being that I work a lot within startups, they're like, well, what can you do? How can you help me out? And I have to tell them, with that free tier, you can actually get pretty close to MVP at almost no cost. Take, for example, let's say you're iterating and you're developing your startup, or you're developing your greenfield software project, or you're working on some internal project, and you're iterating back and forth. Well, what can you get done with that free tier? Well, let's say we've got, we're doing a mobile app. We've got 3 months to launch this, and we're poor. Okay, so not saying all startups are poor, but when I've done my startups, I was poor too. So you want to iterate, and you want to try to get to this MVP as cheap as possible. So let's say you have your dev and test environment, and within there, you want to do internal testing with your team, and you're going to do a 2-tier architecture. So you're going to have a web server on the front end, a database on the back end, and you're going to use our micro instances. So your test environment looks like this. You actually have DNS running, domain name service through our Route 53, which is our programmable, highly available, fast replicating DNS service. You want to use a load balancer in your test environment because you know that when adding a load balancer into your application, things change, and so you want to go ahead and code from day one behind a load balancer. and you want your database layer, and you want your database to be separate from your compute instance. So you have an architecture that looks like this. Now, the really cool thing is that would actually all run free on that free tier. So there's no spend to do that for a year. Full dev and test environment. You can work on your projects. No cost to you for that first year. And he's like, okay, well, that's not a lot of environment there. That's not going to get me to where I want to be. That gets me started, but I got more than I need to do. Okay, that's fine. Let's go ahead and start to build out that architecture. Let's say we want to have maybe an alpha release to internal customers, or we want to show something to core testers. And our architecture starts to look like this. So we've added another compute instance. So now things are actually properly load balanced. I've got a little bit more redundancy. These web servers might be sitting in different availability zones within AWS, so they're actually physically separated in these two different clusters of data centers. And I can test my application, make sure that it's stateless, the sessions are handling properly, requests are getting bounced back and forth. So what does that look like? With that free tier kicked in, you're talking about spending $15 a month. And this is a redundant architecture behind a load balancer, an elastic load balancer. And that spends only $15, taking advantage of that free tier. Let's say you're growing a little bit more now. You actually need something a bit more scalable. You want to scale up, assuming that maybe your traffic is unpredictable and people are starting to hit your website. You also want some more replication on your database end. And so you can do this replica that we talk about with RDS, so that now you've got some redundancy. You're adding some auto-scaling here, so as your traffic goes up, you go ahead and you consume more EC2 resources, and importantly, you also scale those back down. That's looking about $235 a month. And now that's a full best practices architecture there that can handle traffic that is going to be more highly available. It's going to be redundant. It's backed up. You can restore it. So as a startup or anyone who's building something in greenfield or from scratch, you can get to MVP for about $250. That's not bad, and that's a full-scale, a full production-ready environment. Okay, moving on from the free tier. Let me talk to you about reserved instance pricing. And sometimes I think some of the nomenclature might get a little confusing. What do we mean by reserved instance pricing? How do I buy a reserved instance? So to make everything really clear, reserved instances is just an accounting function. It has nothing to do with a particular instance type. And the way we actually figure this out is you can pick 1 year or 3 year, and you pay us a low one-time upfront payment. In return, we're going to get a big discount on your usage. Now, what happens is, let's say you say, I want to buy a medium Windows instance in Singapore. As long as you're running any instance that matches that configuration, you'll get that discount. You don't have to restart any instances. You don't have to change your architecture. It is 100% just an accounting function. Now, we've got these different versions. We've got what's called a light utilization, medium utilization, and high utilization. And this gets a little bit confusing, to be honest with you. When we talk about utilization, we don't mean like the amount of CPU you're actually utilizing. We mean the number of hours that you have it turned on. So a light utilization RI might be something that you don't run but a few hours a day, where a heavy utilization RI might be one that you run all the time. And so you've got some different options here. But if you have no idea what your utilization is, you're using something, let's say below 10%, on demand is probably going to be a better deal for you. But let's say you're running something a few hours a day. You can actually get a light utilization reserved instance for that, and you could see a cost savings up to 56%. Well, let's say you're running something all the time. Like, I know my workload. I'm running a database. I always want to be a medium instance. I'm going to have this on 24/7 for the next year or even the next 3 years. Well, if you purchase a heavy utilization reserved instance for that, you can actually see a savings up to 71%. That is really significant if you think about the overall. And again, it's just purely an accounting function. So if you're running a database, you purchase a reserved instance, either through your account rep or you do it yourself online, that will just get applied to your invoice as it matches your resources to what you bought in your reserved instance. So I want to give you a really good example of a very, very smart customer of ours, a very successful startup. So maybe some of you guys have heard of Pinterest. They run on top of AWS. They are using one of the greatest programming languages in the world, Python, and Django on the back end, and running quite innovatively, I would say, on top of AWS. And I love to talk about these guys because even though they're a really successful startup, in fact, they're extremely successful. One of the fastest, actually the fastest growing social network in the world. massive growth. I mean, they got from 500,000 to 17 million monthly users in 9 months. Just blowing away all the stats. In terms of the resources they consume on top of us, now they're getting into almost, I think, recently, I'd have to check what the numbers are. They're up past, I think, over 500 terabytes of total storage right now through S3, heavily utilizing S3, consuming a massive amount of compute power on top of us to power all those photographs. And here's what's really cool. These guys, they 48.7 million users, $2.5 billion valuation. And this, when they started, when they actually got to $1.5 billion valuation, this was 7 guys running on top of us. You can see I get very excited about startups. Guess what? They run on us very cheaply. Okay, they leverage the heck out of reserved instances. These guys, $2.5 billion, and they're spending at peak $52 an hour on top of us, right? They are not wasting any money on their resources, their IT resources running their business. They're investing all that in innovating and creating new products for their customers, and they're killing it. And so what they've done is they take a mixture of different reserved instances. So at the very baseline, they know at minimum they're always going to be running, let's say, 25, 30 instances. That's their minimum spend. Maybe it's the middle of the night. They're still, I think, a bit heavier on the U.S. side. So they go ahead and they bought heavy reserved instances. And then in that mid-range there, they're able to do light instances, which are not running all the time. So, maybe as they're ramping up 6 a.m. to 9 a.m., they start ramping up servers. They take advantage of those light instances. And then on the top, of course, they're still utilizing on-demand. So you can mix and match these together and decide what is going to be your best combination. But they are extremely aggressive on saving on top of AWS, and they're looking at about 71% less spend at off-peak than they would normally spend. So that's a pretty good model. We have another pricing model called spot instances, and these are a little bit different. Where reserved instances is really just an accounting function. Spot instances have a few different attributes that, in order to take advantage of them, you actually have to kind of know how they work, and you actually need to develop a bit about it. So spot instances, this is our unused capacity within AWS. So obviously we have extra capacity. We have to have capacity to make that elasticity available to our customers. With spot instances, you get to bid on that compute capacity. And regardless of what you bid, we will give you that compute capacity for that hour based upon what the market price is. So let's say, normally you're paying 2 cents an hour for a particular, instance type. During the spot market, maybe it's going to be running at, a third of that. The prices tend to be a quarter or a third of that pricing, that excess capacity. So you can get instances at quite a good deal. The caveat is we will take that away from you without notice and give it to somebody who's willing to pay a on-demand or reserved instance pricing. And if we take it away, we won't charge you for that part of the hour, but we're basically going to send a signal to your instance saying it's going to shut down, and we're going to remove it from you. So you actually you have to be careful on how you want to use this. Some good use cases for spot instances, for example, really, batch processing is quite good for that. So let's say, for example, you have 10 on-demand instances crunching away and doing some kind of number crunching. You could augment it with maybe 40 spot instances. This is actually going to save you money because your on-demand instances are going to cost more than those spot instances. Your job's going to finish a lot faster. Also, well, what happens if you lose maybe 5 or 10 of those spot instances because we had to pool it and give it to another customer, or the spot price went higher than you were willing to pay for it? You're still processing, right? You're still able to get through your batch processing. And so these are really, really good ways to utilize spot instances. We do have some customers who use it in conjunction with auto-scaling, and they, at peak traffic, they try to use spot instances before they move to on-demand instances in order to save themselves money. So you do have to code on that. I mean, for example, if you have a very long transaction, a customer transaction that takes several seconds maybe to complete, or even longer, you're dealing with some kind of session state, spot instance probably not going to be your best choice, right? Because we're going to pull that, and that could destroy that transaction. However, when you're dealing with something that's very atomic when it comes to transaction, requests, restless type APIs, or APIs, or you're doing different types of requests against web servers, then the spot instance might be a really good match for you. A customer who does this really well, who is architected for it, is Vimeo. If you ever use that, Vimeo runs on top of us, right? It's video sharing, and it's got some interesting offering. It's got basically two different models. It's got this freemium model, right? So there's a free offering, and that's for people who don't want to pay anything, and are willing to say, maybe even wait for a day in order to get their videos up. So they use spot instances in this case. They're able to save money. They use the spot instances for the rendering and the transcoding of those videos. They're not having to meet an SLA, a service level agreement, in order to turn around those videos, and so they can save money on that. Now, for the paying customers, these are people who, like companies, for example, they want to post their video, marketing departments, they want that video up immediately. They're going to pay for that. So they're a paying customer. They can use on-demand instances in this case. And so they know that they're going to have that instance. They have maybe a certain number of reserved instances, light use, medium use, heavy use, reserved instances to meet that capacity. And that way they meet that service level agreement for their customers. But obviously, this is something that they had to code for. They had to say, look, we've got a pool of spot instances. We're going to throw jobs to that. If something dies midway through that job because it gets pulled away from me, I can restart that job. I can put it back through the system. So you do actually need to develop your application in order to use spot instances. Reserved instances, you don't have to do anything. Just know what your capacity is. Make sure you understand how you're consuming our services, because you're making a commitment to use that particular type of instance for a year or 3 years. You just want to make sure that, okay, I know I'm going to use a medium, or I'm going to use 5 extra larges. I'm going to keep using it for a year. And then you just buy the reserved instance. Immediately you're going to see those benefits on your invoice. You don't have to do any kind of architecting. So those are the different pricing models. Let's start to get into some of the goodies about how do I actually architect to save money. Now, I never even thought about this when I was an engineer, way back when we had servers, the old days we had servers in rooms, and there were staff. Werner Vogel's is, he himself being a computer scientist, he knows how to build something fault tolerant. But how do you build something which is the most efficient? That's a bit harder. And so let me talk to you about a few different techniques that we can use in order to do cost-aware architecting. First of all, when it comes to compute, we got different things that we can do for caching and offloading. We can take advantage of auto-scaling. We'll talk about some managed services. And then you actually have to size your app for AWS. Then we've got some techniques for storage. There's some options there that you can use to save money, database, and also how can you take advantage of test and dev. All right, so let's dig into some of these goodies. So interesting enough, you've got some different options when you're actually serving content. And I will say this right now. If you are actually using your compute capacity, regardless if it's your on-premises compute capacity, if it's us or some other compute capacity in the cloud, if you are using this to actually serve off static content, you are wasting money on that, because in general, your compute is going to be one of your higher costs, your higher spend. And so the best way and the easiest way to do this immediately is to offload your content. And you've got a couple of different choices on how you can do that. But you should really take advantage of CloudFront. CloudFront's our content delivery network. It's going to spread your content, your static content, around the world. We have 42 edge locations now worldwide. We just launched, as of the day before yesterday, Chennai and Mumbai in India. So that content is now reaching throughout Asia Pacific, and it reaches throughout the world. And this puts no load on your servers. This is the big deal. You can now run with less servers. Instagram, for example, they were analyzing their logs. They thought they could reach so many users with their capacity. They're serving off tons and tons of images. As it turns out, they weren't hitting the numbers that they wanted to hit, and that's because the icon in your search bar up there, the little pictograph that's on the top, the Google symbol when you go to Google or whatever, that was being served off by their web servers, and so they offloaded that content over to the CDN because it's just a static image, and they found out that they could serve a lot more customers with that same amount of compute capacity. So you've got a couple of different options to use our content delivery network, CloudFront, you can actually start using it immediately. It's very easy to integrate in your services. You can have it use different origins. One of the origins, the sources of that static content, can be S3. And by using S3, you have all your stuff sitting up in our simple storage service. It gains about 11 nines of durability, and then you can stick CloudFront on the front of that, and your compute capacity will go down, and your network usage will go down, and you will save money. And how does that look? Basically, customers are going to be able to come into the service. Normally, they're maybe serving everything off of your compute instances. What we can do is add S3, put our content up into S3, and create a CloudFront distribution. And that CloudFront distribution is going to have a CNAME. And that CNAME is what you can reference now for all your static content. And when requests come in for the static content, they will actually go over to the CloudFront server throughout the world, and it's highly available, whatever one is closest to them, and you'll find that your compute capacity will go down. Another way that you can actually do this, you could actually do this right now today and take advantage of some of the free tier, is you can actually tell CloudFront to go to your web servers as your point of origin. Maybe you don't want to change anything right now. And then CloudFront will go and get its requests from your web servers, but it'll only need to get those requests maybe once per hour or whatever your caching header is set for. So you're dramatically going to reduce your overall server usage, reducing your spend with very little change. The only thing you need to do is have your static content now be referred to by maybe a different CNAME. For example, my website is www.jiosub.com, geosub.com. I've got a CloudFront distribution called static.geosub.com, and all my images are served off that. And then, so the only change I needed to make was inside of my templates and my HTML. And so my web servers are no longer serving any of my static content, my images, my photos, my HTML files, my style sheets, etc. A great startup that does that out here in APAC is Perks, which is a loyalty-based company. They are it's a mobile app, and you can go, you can check in. You see when you go to the coffee shop, you want to get your perks because you got your cup of coffee. So it's a mobile loyalty program. And they actually, what's interesting enough, is they've got a lot of content obviously in their app. It's sitting on your phone. They don't serve any of that through their website. That's all getting served through the CDN. Their app doesn't have to worry about it. But the really cool thing about CloudFront is you can actually have it deal with dynamic content. And you can cache dynamic content. You have to architect your app a little bit to work with it. It's going to be through gets. But let's say you're doing something that's showing sports scores. Well, maybe you only have to update that once a second. You can actually have CloudFront cache that, and it'll check for the update every second. But that's going to be constant. Whether you've got one user or a million users, you only have to serve one request a second at that point. You can cache search. You can even cache it with a time to live of 0, in which case it'll open a persistent connection off to your origin server. And if you know about HTTP protocol is fairly inefficient by having a persistent connection, and you don't have to pay that handshake price anymore, and you're going to see a lot of benefits. At the end of the day, what's going to happen is less EC2 instances. Less EC2 instances is going to be less cost, and it's going to bring your cost down. Auto-scaling, okay? This is all based upon the pay-as-you-go model elasticity. Auto-scaling, you can use auto-scaling for lots of different ways to reduce your costs. And I'll give you an example of a customer who does this really, really well here in Singapore. It's a Book. They are a mobile app partner of, if you guys know, the Straits Times, the big newspaper here. And what they do is they have these notifications that go out. So when there's a breaking news story, basically Straits Times alerts them they're going to have a breaking news story. They send out an alert to their customer base. Well, they know that this alert's going to come out. They don't need that much capacity before this big alert comes out. So what they can do is send this alert out, and in 5 minutes, they can actually scale up their servers when it's required. And that way, they're not wasting any compute capacity. They don't have to worry about their peak capacity. So, basically, it looks like this. They work with Straits Times. Straits Times has a traditional data center. They are contacted if there's a news story going out. They send out that alert. And they know at this point they need to start scaling out. Customers start hitting their servers. Elastic Load Balancer, they don't have to worry about that. We manage that. And then, after that morning alert goes out, maybe that news story is not quite relevant anymore, they can scale it back down. Another interesting way, another way you can do cost-aware architecting is managed services. Okay, we have a wide range of managed services that are available. Now, not only is a managed service going to save your precious IT resources, consider a couple of things. For example, are you running a dedicated mail server? Well, what is that going to cost for you to run versus using something like simple email service? How much capacity can that mail server run? When I develop my architectures, I'm a big fan of RabbitMQ. I love RabbitMQ. I think it's a great service. I've also developed stuff using MQ on .NET. However, I had to have a dedicated box running, in order to run that service. I could put the exact same amount of traffic on simple queuing service and not pay for that same price for that running capacity that I need to on EC2. How about running a NoSQL cluster? How many services do you have to have up and running? How many medium instances do you need to run to get that redundancy that you want, to get that performance you want, versus running something like DynamoDB? Or even like, let's say, running MySQL on EC2. You could absolutely manage MySQL on EC2. You can run it on top of a relational database service. On per hour, a relational database service might even cost a little bit more than running it on your own EC2 instance. But think about what you're getting for that. It's being backed up automatically, right? You can do a restore, a point-in-time restore up to any time, up to 5 minutes ago, and those backups are done automatically. You're not running a service to do backups, for example. I'm not wasting my valuable IT time in order to do patching and upgrades. That will relate to a bigger savings overall when you think about your total cost of ownership. Memcache, you run that in an EC2 instance, you can run on top of Elasticache and not worry about it. So consider that those managed services when you're thinking about your total spend, because to run anything on top of an EC2 instance, if you're going to run that 24/7, that's 720 hours compute time. Figure out what that cost is. What's going to be the same cost to do it in simple queuing service? It's going to be less, most likely. What's going to be that cost to use it in simple email service? Probably a lot less. The other thing you want to consider is you want to size your application for AWS. We've got a lot of different flavors of compute. High memory, high CPU. We have cluster compute instances. We have really small instances available, some that are better sized for Windows. We have supercomputers that can kick off. Well, interestingly enough, a medium instance is twice as powerful as a small. It is not twice the cost. So running one medium instance is going to be cheaper than running two smalls. Interestingly enough, you'll probably want to have two medium instances. That's going to be a lot cheaper than running four smalls. Running two larges might be cheaper than four medium instances, but does my application take advantage of that? I code a lot in Python. Python's a bit harder to multi-thread. It tends to work quite better, using up a CPU. Maybe you're running two CPUs. If I throw my my application on a quadruple extra large instance, I'm not going to gain all the benefits I would of that hardware. It's actually going to be cheaper for me to run maybe a bunch of medium instances, maybe even cheaper than running a bunch of larges, because that's the performance I'm going to get out of that. So the good thing with AWS is you can experiment, and I encourage you to do this. If you've got an application, you can turn that into an Amazon machine image. You can launch it in all types of different types of instance types. Find out what your performance is going to be. You can run a load tool against that. Maybe you'll make some tweaks in your architecture to take advantage of a larger instance. But you can reduce your cost. You don't want to waste that CPU. Additionally, you can make some different trade-offs. High memory, for example, tends to be cheaper than high I/O. So do you have a choice there to make, to decide to use a lot of I/O for maybe swapping files, or maybe you do everything in memory, and that's cheaper. And as an architect, that's quite interesting. You can actually take a look at our best cost points and work backwards to decide what cost you want to hit. I want to build something that takes advantage of high memory. Therefore, I'll do lower cost. I want to take advantage of maybe using Linux because of the hourly cost is less. Or, I've got an application, I need a lot of I/O. What's my best choice to do, provisioned IOPS, for example. You can make that different types of choices. And just to give you an idea of what that spectrum looks like, here's some of the different types of EC2 instances we've got available across this entire spectrum. All different types of costs, depending on the type of resources you want. Interestingly enough, too, just kind of going back to using CloudFront and using the Content Delivery Network, when you launch a compute instance on top of us, we have different costs based upon the region you choose. And those costs are reflective of our costs to do business. And so, for example, costs in Tokyo are going to be higher for compute than costs are for US East or for Oregon, and that is, reflective of, for example, higher energy costs, or you have higher tax costs. If you leverage the content delivery network, you can actually locate your compute instances perhaps in a cheaper region, because your latency now is going to come out of CloudFront. It's going to come from that edge location. And so maybe reaching across from where you are, or your customers are, over to some place like Oregon won't have much of an impact, and you can take advantage of that cost savings. So some of this story really is you can size your application for different types of compute instances. And I encourage you to do this and look at those costs and work backwards, and you take advantage of everything. Make sure that when you launch that compute instance, you're getting everything you can out of it. What some people don't know also is S3, our simple storage service. Normally it comes with 11 nines of durability. Well, there's actually something we have called Reduced Redundancy Storage, or RRS. And what Reduced Redundancy Storage is normally with S3, we're going to replicate everything synchronously between 3 different sources, 3 different availability zones in the back end. And that's how we're able to, it's the only way you can get 11 nines, massive amount of redundancy. But sometimes you don't need that amount of redundancy. Especially consider derivatives. Let's, consider having something like you've got a photo sharing application. Maybe you're keeping the original raw image within the normal S3. Well, what you can do then is keep the derivatives, maybe the thumbnails or the smaller types of files or different encoding, in reduced redundancy. This will save you 33% savings on using this. And if for some reason that reduced redundancy is going to have 4 nines of durability, but let's say for some reason something happened, you lost that, someone deleted it, you had loss, it will actually be cheaper in the long run for you to go ahead and spin up more EC2 instances, create those derivatives again, spin them back down, and take advantage of that cost savings. But again, you have to architect for that, right? You have to know that you want to do that. Database side. So databases tend to be one of the more difficult things to scale out, right? You tend to have to put it in bigger and bigger instances. You get to that, quadruple extra large database instance, you're spending quite, a bit per hour to run that database. Well, consider caching, for example, that you can offload things from the database. Partition your data to decide what's your read and your write data. If you can have something that's heavy read data and you know that it's a little bit different data, caching's fantastic. You can launch Elasticache. You can now cache those read requests and perhaps have a smaller RDS instance. And you can also make it so that you can combine this with offloading to DynamoDB, for example. With DynamoDB, you can tell us how fast you want it to run and be able to use smaller database instances. And then you can also take advantage of these read replicas that you get with RDS. And with a read replica, you can use that for your reporting. You could even have it so that you have read replicas that maybe aren't even on all the time. And you can lower your traffic on your main master database server. This means that, for example, maybe you don't need a giant quadruple extra large database, which is having a lot of reads and writes, and they're conflicting, so you're getting a performance decrease because you can't do the reads because the writes are going in. And maybe you've got a smaller master, like a medium, a couple of read replicas, and you offload that traffic. And then you can have your EC2 instances to go, oh, I'm going to go over to, for all the reads, I'm going to hit these read replicas, and I partition my data, so my deletes and my updates, my inserts are all going to go to that master database, and I'm going to let that replication take care of it. Same with being able to use Elasticache. You can sit between your server and your database and cache those requests. And some frameworks actually work beautifully with Elasticache. Elasticache is just Memcache, it's managed Memcache-D. And so, for example, if you're using like Django as an example, it's got a JSON cache, I believe it's called. It automatically will put all the read requests through Elasticache and invalidate stuff when there's writes. You don't even have to know it's running, and then you'll find out that your performance goes way up and your database's load goes way down, thus saving you some money. For example, you can do 90% of your calls through that. It depends on exactly what infrastructure you're using. But you can see the difference by using CloudWatch, and I'll tell you if your CPU of your database is going down. Okay. You can also use this for test and dev, and this is going to allow you to do rapid prototyping. One of the idea is there, in addition, is to be able to do your sizing. So you can set up a bunch of different instances, find out if you want to use a medium size or a small size. You can use it for A/B testing, for example, for different architectures very cheaply. You can actually have your architecture grow so that the capacity, if more people are choosing type A in your A/B testing, you can have that capacity grow with auto-scaling. And if people aren't using B, don't waste money on it. Let it scale it back down. It'll use less resources. And you can use different tools from us like CloudFormation, Elastic Beanstalk to automate all this so that you don't have to do it yourself and to build out all your different architectures quite easily. So let me bring this all together. Before I do this, I just want to do a quick poll. I just want to see how many people on the poll, if you get a chance here, have you actually architected to take advantage of some of the different cost savings on AWS? So we'll just bring that poll up right now. And have you taken advantage of RIs? Have you actually programmed your architecture in order to, take advantage of reduced redundancy or spot instances? So just votes are kind of coming in now. It looks like the majority of people on this webinar haven't actually done that. So I'm hoping that you will start to take advantage of some of these different techniques. Again, if you need any help when that survey comes up, we will call you up and we will help you spend less money on us. That's just the kind of people we are. So bringing this all together, what does this look like? And I'm going to give you an example of a real startup out here in Asia Pacific. This would apply just as well to an enterprise or anybody who's developing an application on top of us. This is a really good startup, strong growth, getting profitability. We worked extremely close with these guys to help them in cost savings. So here is what their costs actually look like, and here's where the revenue went up, and they did quite well. So what happened is, first of all, immediately they get advantage of dropping our S3 pricing, and then, they figured out their workload. They're able to drop their costs again through reserved instance purchases. They were managing their own NoSQL database, Cassandra, a really fantastic NoSQL database. They were able to get cost savings by moving over to Dynamo using less EC2 compute time. Another price drop. Get that automatically. Don't have to do anything. That's a freebie. And that means that their margin growth increased. As they consumed our services, their costs, they were able to keep knocking those costs down. That means their unit costs actually went down by 54%, which is a great way to do it. So a couple of things, just so you know about a bunch of stuff in the free usage tier, a bunch of free services in that tier, and there's no charge for inbound data transfer. You want to do backups, you can send as much data to us as you want. There's no charge on our end for that. I also wanted to point out Trusted Advisor. If you're using support on top of us, if you're using enterprise or business level support, you get Trusted Advisor. That's included. Trusted Advisor actually has a tab for cost optimization, and it will go through and it'll inspect your infrastructure and say, hey, you've got these EC2 instances that have been idle most of the time. Or, hey, it's really cool. It'll do RI purchase recommendations. It'll say, hey, did you know that if you would purchase heavy RI instances, 4 of these, you would save X thousands of dollars a year. You get that automatically with business level or enterprise support. If you're interested in cost savings and you don't have support, just like everything else that we have at AWS, it's a pay-as-you-go model. Sign up for business support for a month. Run Trusted Advisor. You don't have to renew business support after that if you don't think you're getting value out of it. It might run a report immediately, tell you different ways to do cost savings. Or contact us. Happy to help you guys. Happy we can even run a reserved instance model against your architecture to give you advice on getting reserved instances. Okay, guys, we're just running out of time. I'll try to save 5 minutes for some Q&A. Real quick poll question. I just want to see if you think this presentation will help you reduce your costs on AWS. And while that poll is running, just another reminder here that you want to be able to fill out the survey that's going to come up at the end and get that $25 in credits. Did you run the poll? The poll. Run the poll. Yep. And what we'll do now is I just got 5 minutes. I'll go ahead and answer some questions. Also, just keep in mind too. Here's my contact. If you need me, you can follow me on Twitter. I will not obviously be able to get to all these questions, and I apologize for that. For questions not answered, just put it in that survey form. We'll have somebody reach out for you and be able to answer it. So let me just see what if you got any questions here. It'll just take me a second just to look at them. Just give me a second, folks. Let's see. How to use spot instances in an auto-scaling group. That's a good one from Drew. You actually have that option now. It's a feature we added recently. When you create your auto-scaling group, you can specify to consume spot instances. Keep in mind you might lose them, but for scaling up for excess capacity, a lot of customers are actually using spot instances. Be sure, though, that you don't have things like sticky sessions on the load balance, so you're not maintaining a lot of state. Because if you're in the middle of a long transaction, we'll pull that spot instance out, and that customer will lose their session. So as long as you develop your architecture soundly, you can absolutely use spot instances for auto-scaling. If I have spot instances and you pull it away, what about my data on that instance? So essentially the question is, I've got a spot instance, and we pull the instance away. What about my data? I have a setup. So you've got a couple of options there. So first of all, you can always create an Amazon machine image as your base template. Let's say you've got a configuration that you want to use. You base your spot instance on this AMI. So you build everything up on that instance. You configure it the way you want. And when we spin up that spot instance, you say, hey, use this AMI. It's already pre-configured. It has configuration. If you've got state, if you're actually storing state on the EC2 instance that you want to keep around, which I don't recommend, but sometimes you have to do that, you will attach an EBS volume to that, and that EBS volume will stay persistent. So even though we pull that EC2 instance, that virtual hard drive is still going to exist with an EBS. When you spin up another spot instance or an on-demand instance even, you can reattach that EBS volume. Can I restrict my spend by setting a limit of X per month across all services I've subscribed to? So you can't actually restrict your spend. That is a feature that has been asked by customers. The difficulty with that being is, let's say you're going to go over your spend. What would you want us to do? Most customers wouldn't really want us to turn their web servers off, because they've run out of compute. Like you're on an important phone call and you run out of your prepaid minutes, suddenly the phone hangs up. Probably not the best experience for our customers. So what you can do, though, is you can set up these billing alerts. And you can have it so that we will tell you as your spend approaches these different alerts. And that's completely configurable. It's part of CloudWatch. You can do it through the web UI. You can do it through the API. And so, like, I've got one set on my own account. I want to know when I reach X amount, and then I have another one when I reach another X amount. And then that way I can decide myself, maybe I want to pull back some instances. Maybe it's okay that I don't serve as many customers. But we won't do that in an automated fashion. I just don't think that'd be a great experience. Does S3 and CloudFront apply for video content? Yes, you can absolutely do streaming on CloudFront. So you can set everything up. You can put your video files within S3, and we have different streaming and different streaming protocols that are available for CloudFront. NASA did that if any of you guys watched the Curiosity on Mars, that was watched worldwide. That was streaming through CloudFront. And so same with Netflix. So you get all that. You get that same infrastructure. It's available to your company that is used in the biggest organizations in the world. Ooh, here's a hard one. Let's see if I can answer this in 2 minutes. We have our product based on a Liferay portal, which is on AWS EC2. We put our servers in US East Zone A as reserved instances. We're using RDS and our DBS. How can we leverage auto-scaling and CloudFront? So with CloudFront, immediately stick all your static content in an S3 bucket in US East. Point CloudFront for your distribution. Give it a different name, so it'll come up with the CNAME CloudFront, blah blah blah.cloudfront.net. Make that be static.mycompany.com. You can use DNS or DNS Service Route 53 to do that. Point that as your static content. Now change all your HTML so that whenever it refers to an image or a style sheet or even if JavaScript, have it go to static.blah.blah.com. Then immediately all that content will now be running through CloudFront. If somebody from Europe hits it, it'll be served out of possibly London. If somebody from Dallas hits, it will be served out of Dallas. The next step then is to do dynamic content. And if you can do dynamic content through us, basically, as long as you can do it as a GET, it doesn't handle puts yet, but as long as you can do it as a GET, you can have all that go through CloudFront, have it cached. You can even do a TTL of 0. And now what happens is as people start to pull from servers, you only have to serve CloudFront. So CloudFront will reach through our own internal, if it's over in the US East, it'll reach it within the same region, or it'll reach across regions to your origin, which is your EC2 instances. But it will handle all that traffic, and you'll find that your balance, your overall load will go way down. So I'm afraid we're out of time. I thank you so much, guys, for listening to me droll on here for the last hour. I'm sorry I couldn't get to all your questions. Please fill out that survey. Put your questions in that survey. We will have somebody contact you, and hopefully, spend less money on us. So once again, thanks a lot. Bye-bye.